All right, Chem, this is Miss Boston again. Now we're going to learn how to name binary covalent compounds. Now, covalent compounds are different than ionic compounds. Ionic compounds are formed by the transfer of electrons from metals to nonmetals. Covalent compounds are formed by sharing electrons. Sharing electrons occurs when two nonmetals bond together. Now, you might say to yourself, wow, there's mostly metals on the periodic table of the elements. So most compounds must be ionic. But the reality is that covalent compounds can form huge compounds. They can form tiny ones between two atoms, or they can form huge ones with hundreds of atoms in there. So the reality is most of the compounds on the planet, the different kinds of compounds are covalent. So let's go over what it means to be a covalent compound. I'll start with one that we likely already know. Now you might say to yourself, I already know how to name that. So that's going to be helpful to us because it's going to teach us how to use the flowchart to name covalent compounds. So we're going to start up here with, does the compound start with H plus like we did before with ionic? It does not start with H plus. Carbon is in the first position. So we're going to go down the no route. Does not start with H plus. Is the compound binary? Well, binary means two. So it's got carbon, it's got oxygen. So the answer is yes, it is binary. Doesn't matter how many carbons or how many oxygens. It's just how many different types of elements are involved. Now it says, is there an ionic or covalent? Ionics have a metal first. Covalents have a nonmetal first. So you go to your periodic table of the elements, you see that carbon is a nonmetal. Now it says, use prefixes to describe subscript, prefix plus first nonmetal, prefix plus second nonmetal stem, plus IDE. Well, that's a little confusing, but let's walk through how we decipher that. You'll look in your list of polyatomic ions, and over to the side of the list of polyatomic ions is a chart of prefixes. And it's going to say mono for one. And then if it doesn't say this already, you need to write this. You need to write not on first. What that means is mono indicates you have one atom, but we don't use that on the first compound. The other prefixes we do use on the first compound. Mono we use on the second compound. So di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Those are the prefixes that you use to indicate the subscripts for a particular nonmetal. Now, this is opening Pandora's box for me, because once I talk to you about prefixes, you're going to want to put them on all compounds. You're going to go prefix crazy and use prefixes for metals. These are only for nonmetals. These are only used on binary covalent compounds. So these are only for nonmetals involved in covalent compounds. So before you go prefix crazy, double check that you're involved in a covalent compound. So let's say this says use prefixes to describe the subscripts. So prefix plus first nonmetal. Prefix for carbon has no subscript, so it's subscript 1 understood, but not on first. So this is carbon. And then it says second nonmetal stem plus IDE. Di. And we'll change oxygen to oxide. This is carbon dioxide. So we're going to do a bunch of these, just if that probably seemed awkward at first. So let's do another one that we probably know. These are all going to be covalent compounds, so two nonmetals bonded together. So this whole video is going to be this box right here. And this is going to be carbon, because it does have the subscript of 1, but we don't put mono on the first. The subscript on oxygen is also mono, but we do use it on the second. So this is carbon monoxide. How about this one? This is laughing gas. This is what doctors use to relax patients at the dentist office. So we're going to say nitrogen is first. It is a nonmetal. This is a covalent compound. So we're just going to use our prefixes. We're going to read it and write it down. We're going to see that nitrogen has a 2. So it's going to be di-nitrogen. Oxygen has a 1. So monoxide. P5O10. Once you recognize that phosphorus is a nonmetal, you know you're going to be using your prefixes to describe the subscript. The subscript for phosphorus is 5. We'll go over here and see that 5 is penta. Then we're going to go to oxygen. Oxygen is 10. So its prefix is deca. So it's pentaphosphorus decaoxide. Here's another super common one that you may not think you know, but you probably do. So let's analyze this guy. Si is silicon. So let's go back through the chart again and make sure we understand what we're doing. So it doesn't start with H+, it starts with silicon. So go down here. It's binary because it's just got silicon and oxygen in there. So it's going to end in IDE. Notice every time we go binary, we end in IDE. It is covalent because silicon is a nonmetal. So we're going to use our prefixes. We're going to use our prefixes to describe our subscripts. Silicon's subscript is 1, but it's in the first position. So we just name him. He doesn't need a mono on the first, so he's silicon. And then oxygen's subscript is 2. 2 is di. So this is silicon dioxide. Silicon dioxide is one of the components of glass. It's also a component of sand. So silicon dioxide is a super common compound all over the world in all of the sand that you see. So we also take it and use it to turn it into glass. I also want to add something in here for common covalent compounds that can be named systematically, but typically go by their common names. So for example, let's go to the example that's in our first box there, H2O. We all know what H2O is. It's water. It goes by its common name, but we can systematically name it also. We can see that hydrogen has a 2, so it's dihydrogen. And then oxygen has a 1, so it's monoxide, dihydrogen monoxide. We typically don't put the 2 O's together, so it wouldn't be monooxide. So if you're ever bored one day, if you Google dihydrogen monoxide, there's all sorts of jokes about that, because if you looked up the MSDS, which is Material Safety and Data Sheet for water, that's what OSHA uses and what we use to tell everybody about the dangers of chemicals that might be in a lab or something like that. The one for water is actually pretty interesting, because water is necessary for life, but if you think about it, water can also be deadly. You can die, you can drown in it. Water is also deadly if you drink too much of it. Here's another compound that goes by its common name, but can be named systematically. This is nitrogen's a nonmetal, so this is a covalent compound. Remember, that's the only time we use this prefixes is when we have a covalent compound. This would be mononitrogen trihydride, except we don't put mono in the first spot, so it would be nitrogen trihydride. But it goes by its common name of ammonia. And our last one that is a covalent compound, because it starts with a nonmetal and it occurs all around us. We use it all the time. It's a covalent compound. So if you systematically named it, it would be carbon tetrahydride. But its common name is methane. So here's how you name covalent compounds. And I'm going to remind you one more time. Now that I put these coefficients out there, you guys are going to want to throw them around everywhere. You're going to get coefficient crazy and put them on every compound. But they're only for covalent compounds. So if there's not a nonmetal in the first position, do not use these coefficients.